Anthony Raj. He has pursued his bachelor's, master's, and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Tiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to UGC lecture series BArc Semester 1 Mathematics Lecture 5. In this lecture we are going to see three-dimensional analytical geometry. In three-dimensional analytical geometry, in this lecture we are going to learn equation of a plane, equations of a straight line, then summary. Equation of a plane. You know, every equations of first degree in x, y, z represents a plane, and we know that plane is a two-dimensional object. So every equations of first degree in x, y, z represents a plane. The general equation of first degree in three variable is given by ax plus by plus cz plus d is equal to 0. Keep this as equation 1. In this equation, this x, y and z are the coordinates. A, B, C are the real constants. Otherwise, we can say this A, B, C as coefficients of x, y, z. So this is how the general equation of first degree in three variable can be formed. So ax plus by plus cz plus d is equal to 0 gives an equation of a plane. In this equation, these a, b, c, d are real constants, and at least one of the a, b, c is non-zero. That means simultaneously all the three a, b, c should not become 0, then we will not get the equation of a plane. Now let P and Q be any 2 points on the surface given by the equation of a plane. Here P is a point and Q is a point. This P has coordinates x1, y1, z1, and Q has coordinates x2, y2 and z2. These 2 points are any points on the surface of the given plane represented by the first degree equation. Then ax1 plus by1 plus cz1 plus d is equal to 0. Assume this as equation 2, and ax2 plus by2 plus cz2 plus d is equal to 0. Assume this as equation 3. These two equations are obtained from the general equation of a plane considering the points P and Q whose coordinates are x1, y1, z1 and x2, y2, z2. Now multiply these equation 3 by lambda and add that to the equation 2. So if we do so, we will get this expression, that is ax1 plus lambda x2 plus b into y1 plus lambda y2 plus c into z1 plus lambda z2 plus d into 1 plus lambda is equal to 0 is the expression obtained after multiplying equation 3 by lambda and adding that result with equation 2. Now divide this result by 1 plus lambda. If we do so, we will get this expression, that is a into x1 plus lambda x2 over 1 plus lambda plus b times y1 plus lambda y2 by 1 plus lambda plus c times z1 plus lambda z2 by 1 plus lambda plus d is equal to 0. So, in this expression you can see that that lambda figures in the equation. Here we are going to get the equation of a plane which contains the points p x1 y1 z1 and q x2 y2 z2. To get the equation of the plane, we are doing all these mathematical manipulation. Now, let us keep this equation as equation 4. From that equation 4, we observe that the points x1 plus lambda x2 by 1 plus lambda and y1 plus lambda y2 by 1 plus lambda, then z1 plus lambda z2 by 1 plus lambda satisfy the equation 1, that is ax plus by plus cz plus d is equal to 0 is the equation 1. This equation will be satisfied by the point this point, and this point is on the straight line joining p and q. So, lambda is a parameter, so it can be taken any real value except minus 1. Hence, all the points on the line pq are satisfied by the equation 1, ax plus by plus cz plus d is equal to 0. So, that this equation ax plus by plus cz plus d is equal to 0 represents a plane in general form. So, in this explanation you learnt that the equation of a plane contains the point p and q. Coordinates of that point p and q are x1 y1 z1 and x2 y2 z2. Then equation of a plane containing the point is given, then that two equations are manipulated, then we got a point x1 plus lambda x2 by 1 plus lambda, then y1 plus lambda y2 by 1 plus lambda, z1 plus lambda z2 by 1 plus lambda is the point we obtained. Then this point satisfies that plane equation. So, that equation ax plus by plus cz plus d is equal to 0 represents a plane in general form. In that expression, in the equation of that plane, you can note that the coefficient ABC represents the direction ratios of a normal to this plane. You know, normal means a perpendicular line drawn to that plane. So, direction ratios of that normal are represented by the coefficients of A, B and C. Then from this equation of a plane, following corollary can be learnt. That is, corollary 1, general equation of a plane passing through a given point. That is, let A be the point and the coordinates of that A are x1, y1, z1. Let the equation of a plane be ax plus by plus cz plus d is equal to 0. Now, this plane passes through the point a1 a of x1 y1 z1. Then we get the equation of a plane as ax1 plus by1 plus cz1 plus d is equal to 0. So, from this corollary what we learnt is, if any point any plane passes through a point, then combining the point and the plane will get an equation like ax1 plus by1 plus cz1 plus d is equal to 0. Now, subtracting these two equations, that is equation ax plus by plus cz plus d is equal to 0 and ax1 plus by1 plus cz1 plus d is equal to 0, we will get a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This is the required general equation of a plane passing through the point x1, y1, z1. So this corollary gives us the equation of a plane passing through a point. Next, corollary 2. In this corollary, equation of a plane that passes through the origin is given. The equation of a plane that passes through the origin is given by ax plus by plus cz is equal to 0. So this is the equation of a plane which passes through the origin. Corollary 3. Equations of the plane parallel to the coordinate axis are given by, if a is equal to 0, then the equation of the plane will be by plus cz plus d is equal to 0. This plane is a plane parallel to the x-axis. So in a plane equation, if x component doesn't exist, then that plane is a plane parallel to the x-axis. Then the second one is, if b is equal to 0, then the general equation of the plane will reduce to ax plus cz plus d is equal to 0. This plane is a plane parallel to y-axis. Here that y component is missing, y part is missing. So in any plane equation, y part is missing means that plane is a plane parallel to y-axis. Similarly, if the z part is missing in an equation of a plane, then that plane is parallel to the z-axis. In that case, if c is equal to 0, then ax plus by plus d is equal to 0 is the plane parallel to the z-axis. So these are all the different corollary we get from the general equation of a plane ax plus by plus cz plus d is equal to 0 is a general equation of a plane. First corollary is equation of a plane which passes through a point, that is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Then an equation of a plane which passes through an origin is given by this ax plus by plus cz is equal to 0. Then equations of the plane parallel to the coordinate axis are given by these three expressions. So from this explanation, you learnt that general equation of a plane and different cases in the equation of a plane. Then the next important part in the equation of a plane is intercept form of a plane. The equation of a plane which cuts the coordinate axis gives the intercept form of a plane. That means that plane interfere the coordinate axis. In such case, the equation of the plane is given by x by a plus y by b plus z by c is equal to 1. Here this a, b, c are the intercept of the plane with x, y and z axis. This is the intercept form of a plane. Next thing is normal form of a plane. Here in normal form of a plane, a perpendicular distance from origin to the plane and direction cosines of this perpendicular is called normal form. So if an equation of a plane is given in terms of a perpendicular distance from origin to the plane and direction cosines of this perpendicular, then normal form of a plane will come. That normal form of a plane is given by Lx plus My plus Nz is equal to P is the equation of the normal form of a plane. Now equation of a plane passing through 3 points. you are given 3 points like x1, y1, z1 and x2, y2, z2 and x3, y3, z3. These are the 3 points given. Suppose a plane passes through these 3 points, then equation of that plane can be given in this form. That is, determinant of x, y, z1, first row contains x, y, z and 1. Then second row has x1, y1, z1, 1 and third row of the determinant got x2, y2, z2, then x3, y3, z3, 1 is equal to 0 is the required equation of a plane passing through the 3 points. Equation of a plane passing through 3 points. Equation of a plane passing through 3 points is given by the determinant form. In that determinant form, the first row has x, y, z and 1. Second row has x1, y1, z1, 1. Then third row is x2, y2, z2, 1. Fourth row is x3, y3, z3, 1. So, the determinant has 4 rows and 4 columns. Then the value of the determinant should be equal to 0. You will get an equation that if you expand this determinant, you will get an equation. This equation is a required equation of a plane passing through 3 points. So, here we have seen, so far we have seen the intercept form of a plane, then normal form of a plane, then equation of a plane passing through 3 points. Now, we will apply all these equations of a plane or concepts of a plane in a problem. So, in this example, a plane meets the coordinate axis in ABC such that centroid of the triangle ABC is a point PQR. Show that the equation of the plane is x by p plus y by q plus z by 3 is equal to 3. So, in this example, it is learned that the equation of a plane is given in intercept form. So, that in the example it is given that the plane meets the coordinate axis in ABC. So, that is the intercept of the plane in the coordinate axis. So, we need to show that the equation of the plane is x by p plus y by q plus z by r is equal to 3. This problem can be solved in the following way. First, let us take the equation of the plane as x by a plus y by b plus z by c is equal to 1. This is the general form of intercept form of a plane, general equation of intercept form of a plane. First, you take that. Next, the plane represented by equation 1 meets the coordinate axis in A, B and C at the points A, B and C, where A has the coordinates small a, comma 0, comma 0 and B has the coordinates 0, comma b, comma 0 and C has the coordinates 0, comma 0, comma c. Now, the coordinates of the centroid of the triangle ABC is a plus 0 plus 0 by 3, comma 0 plus b plus 0 by 3, comma 0 plus 0 plus c by 3. So, in this the centroid of the triangle ABC, the general formula to find the centroid of a triangle is used. So, simplification of this formula gives a by 3, b by 3, c by 3. So, this a by 3, b by 3, c by 3 is the coordinate of the centroid of a triangle. Already we have assumed that centroid of the triangle is given as PQR. This is also the centroid of the triangle. Now, we equate these two. If we equate these two, we will get P is equal to A by 3 or A is equal to 3P. Like that, we will get B is equal to 3Q and C is equal to 3R. So, from the equation of the centroid, we got the values of ABC. The reason for obtaining the values of ABC is in the equation of intercept form of a plane, this ABC are the intercepts. We got the ABC values in the form of PQR, then substitute these values in the intercept form of a plane. Equations of the intercept form of a plane will get 3 by P plus y by 3q plus z by 3r is equal to 1, that is x by 3p plus y by 3q plus z by 3r is equal to 1. Simplifying this, we will get x by p plus y by q plus z by r is equal to 3. This is the required condition to be proved as given in the problem. In the problem, it is asked that show that the equation of the plane is x by p plus y by q plus z by r is equal to 3. By the steps we followed in the problem, we have proved this x by p plus y by q plus z by r is equal to 3 is the equation of the plane. Example 2. In this example, it is asked that find the equation of the plane passing through the point P. Coordinates of the point P is 2, 3, minus 1 and perpendicular to OP, where O is the origin. So, here a point form is given. So, to find we need to find the solution of this problem. Solution to this problem can be obtained like this. First, we need to get the equation of a plane passing through the point x1, y1, z1. So, this is the point through which the plane passes. That equation is a into x minus x1 plus b into y minus y1 plus c into z minus z1. This is the general form of equation of a plane passing through a point x1, y1, z1. Now, substitute the values of x1, y1, z1. According to the problem, x1 is equal to 2 and y1 is equal to 3 and z1 is equal to minus 1. Now, substitute these values in the equation. We will get a into x minus 2 plus b into y minus 3 plus c into z plus 1 is equal to 0. Keep this as equation 1. According to the problem, this equation 1 is perpendicular to OP. Perpendicular to OP. Now, the directional ratio of OP are 2 minus 0, 3 minus 0, minus 1 minus 0 are the directional ratio of this OP. Directional ratios of OP. So, the directional ratios will be 2, 3, minus 1. These are the directional ratio. These directional ratio are proportional to A, B, C. Therefore, we will get A is equal to 2k and B is equal to 3k and C is equal to minus k. Since this directional ratio is proportional to the intercept, we got this values A is equal to 2k, B is equal to 3k and C is equal to minus k, where k should not be equal to 0 and the value of k must be a real one. Now, substitute the values of A, B, C in equation 1. We will get 2k into x minus 2 plus 3k into y minus 3 minus k into z plus 1 is equal to 0 is the equation obtained after substituting the values of a, b, c. Now simplifying this equation, we will get 2 into x minus 2 plus 3 into y minus 3 minus z plus 1 is equal to 0. Since k is not equal to 0, this is the equation obtained after simplifying the above equation. Now simplifying this equation further, we will get 2x plus 3y minus z minus 14 is equal to 0. This is the required equation of a plane which passes through the given point and perpendicular to OP, a line drawn from the origin. So from this problem, we learnt that how to find the equation of a plane passing through the point and perpendicular to a line. Then equations of a line. Equation of a line can be obtained in different form. Among the different form, the symmetrical form and non-symmetrical form are the two major categories. First, let us go to the symmetrical form. In this symmetrical form, to obtain the equations of the straight line which is passing through a given point whose coordinates are alpha, beta, gamma and having the directional cosines L, M, N, let OX, OY, OZ be the rectangle axis with origin O and let A be a point whose coordinates are alpha, beta, gamma as shown in the following figure. This is the coordinate system. In this coordinate system, this is x axis and this one is y axis and this is z axis. Here O is the origin, then a point A is assumed here. Coordinates of that point is alpha, beta and gamma. Then another point P is assumed here. Coordinates of this point are x, y and z. Then joining these 2 points, that is A and P, will get a straight line. So we are going to get the equation of the straight line. Let P of x, y, z be any point on this line having the directional cosines L, M, N. Therefore, the directional ratios of the line AP are x minus alpha, y minus beta and z minus gamma. So using this directional cosines, the equation of the line is given by x minus alpha by L is equal to y minus beta by M is equal to z minus gamma by N is equal to AP is the symmetrical form of a line. So from this explanation, we learnt that how to get the equation of a line in symmetrical form. From this thing, we got two corollaries, that is equation of a line passing through a point and equation of a line in symmetrical form passing through 2 points. In non-symmetrical form, a straight line is the intersection of 2 planes. So these 2 equations give the equation of a straight line obtained by the intersection of 2 planes. Here equations of 2 planes are given. These equations will act as equation of a line. So in this lecture, we learnt that equation of a plane. So every equation of first degree in x, y, z represents a plane. The equation of a plane in intercept form is given by x by a plus y by b plus z by c is equal to 1 is the equation of a plane in intercept form, where a, b, c are the intercepts. Then equations of the plane in normal form is given by Lx plus My plus Nz is equal to P. Then we discussed equation of a line in symmetrical form and non-symmetrical form. In symmetrical form, equation of a line is given as x minus alpha by L is equal to y minus beta by m is equal to z minus gamma by n. That is the equation of a line in symmetrical form. And in non-symmetrical form, we got the equation of a line as an intersection of two planes. So these are the concepts we discussed in this lecture. After listening to this lecture, you can answer the following questions. Give the equation of a plane in intercept form and normal form. Find the equation of a plane passing through points 0, minus 1, 0, 2, 1, comma, minus 1 and 1, comma, 1, comma, 1. Then find the equations of a plane passing through 3, 4, 5 and 2, 3, 4. These questions can be answered after listening to this lecture. Thank you.